10, you can treat them as if they're all x's, the exponents, when you put them together. So you can look at the 10 to the power stuff separate, and then as far as the numbers, you do like you normally would. You got 2 on top being multiplied and then dividing by the 1 on the bottom. So let's go through and collect the like stuff. I'm going to deal with 2 on top first. That's my personality. It doesn't matter how you do it. It doesn't matter if you pull the 1 on bottom up first. I'm going to personally look at these 2 first. And in fact, I'm going to go ahead and multiply those 2, just because it'll make me more comfortable. Remember, it's all multiplication. Order is not that big of a deal as long as you're following the rules. So go ahead, guys. What is 3.2 times 2.9? Since we, remember we treat the coefficients. 9.28. Perfect. Times 10 to the. Now, when we're looking at stuff with similar bases, we have a negative 11 and a positive 15. So we have 10 to the negative 11 times 10 to the 15. Bases match, so what do we do across those powers? You add, okay, so we're going to get 10 to the what? Okay, sounds good. So times 10 to the 4th. That's our thought bubble for what we just got below. Okay, so we've just got condensed the top. Now we have 8.1 times 10 to the negative 3. Now, same as before, I'm going to look at my 10s. Which one is smaller? Which one am I going to kill? Okay. So when I kill that, I go to the 4 and say minus a negative 3, right? So that becomes a plus. So I'm going to get 10 to the power of what? Okay, so 10 to the positive 7. And then with these numbers, somebody divide that for me in your calculator. What is 9.28 divided by 8.1? You'll get some decimal.
Yeah, 1.145. And then
1.145?
Yeah, then it keeps going.
Lots of zeros? Okay.
6, 7, 9, 0, 1, 2. I'll just talk around.
Okay, let's actually write out a little bit more because the book writes it out quite a bit. Since it's going to make us do decimal notation in a second, normally you'd be able to just round it a little bit, but since the directions in the book say don't stop with scientific, write it out long, let's try all the decimals we get that way. That'll be helpful. Okay, let's start again. 1 point what?
1, 4, 5, 6, 7, 9, 0, 1, 2.
Okay. And obviously it looks like it's not repeating or terminating. It probably keeps going, but we don't need that many. We only have a 7 there. So this is the scientific notation version. If we want to write it in regular form, what does that 7 mean to us, that 7 on the 10? Are we going to make the number bigger or smaller when we start walking? Bigger. By how many steps? Okay. So 7 steps to the right is what we're going to do. So we start here, 1, 2, 3, 4, 5, 6, 7. So we have something like that. I'm looking to see if it's right. That looks right. And you can leave 0.12 if you wanted, I suppose. The author actually stops just with the whole number part, though. He says that's enough. But the important thing is that you got enough numbers that when you walk that decimal over, you didn't just have lots of zeros. That's why we went ahead and wrote them out. Other questions or comments? So this is from 6.1, right? What I would do with 113 first, Kel, is I would actually convert that to scientific notation and do it just like this one. Did you try that?
Yeah.
But you still had trouble with it?
I messed up on my positive and negative.
Let's look at it then, because I don't want you to not get it if you did it that way. Okay. Remember, this isn't a primary focus of what we've been learning. It was just kind of a, how many zeros are there before that 4? 7. It's not a primary focus of what we've been learning. It's just they were showing us more exponential stuff. Remember, the main focus as you go through and study for this test, this is going to be on there, but mostly the stuff with the A's and B's and X's and Y's, that's what you're going to have a lot of from this section with the variables. So this was just kind of showing you why you'd actually care in real life too, if you were dealing with measurements. Those are my commas, even though they look kind of bad. So 113 from your text. First thing I would recommend doing is putting it in scientific notation. So that's what I'm going to do. I'm going to take this one, 1, 2, 3, 4, 5, 6, 7, 8. So I've got a 4 times 10 to the negative 8, since that was a small number to start with. Right? Everybody with me? That was 8 steps. And then here I'm going to go from this starting point 1, 2, 3, 4 times. That's 4 steps. So I'm going to say 8.4 times 10. That was a big number to start, so I'll use a positive 4 so the person knows it was a big number when they start trying to convert it back if they did want to do that. Everybody okay so far? Same thing down here. I'm going to move this decimal so there's one normal number, not a 0, to the left-hand side. So I'm going to give 3 times, that was 1, 2, 3, 4 steps here. So I'll put 10 to the, I guess, negative 4, since that one's a small one, right? Since that was a little one to start with. Then with this one, we have a big one, 1, 2, 3, 4, 5, 6. So I have 1.4 times 10 to the 6th power. The reason I do that is because it just makes it faster. You can put those 10s together in no time. Remember, since we have multiplication and division, that's the only reason this is so nice. If we had addition or subtraction, it messes everything up. Remember from 6.2, we said to go back to the more simple way of looking at it, because you didn't have as much power when you were just adding and subtracting. With this right here, though, it's all times, all division. It's good to go, whatever order you like. You want to combine it top to bottom, whatever. I'm going to go side to side. That's my personality. I like to look at a fraction, condense the top of the fraction, then to the bottom, and then do more. That's what I usually do in this problem. So my approach is going to be to look at my 8s on top first, or my 10s on top first. So I'll be getting a 10 to what power? Let's see, negative 8 plus 4, negative 4. Please fit, okay. And then I have, let's see, a 4 times an 8.4. What's that? 33.6 times that stuff, okay. Everybody okay? It's not scientific, we don't even care right now. We'll deal with the not scientific part in the very last step. When, some stuff's getting shifted. We're just dealing with our variables right now in an easier way. Okay, same thing on the bottom. I'm gonna multiply these two 10s. Since it's the same bases, all I do is add the powers. So negative 4 plus a 6 gives me 10 to what power? Okay. And then we have a 3 times a 1.4. $4.2. Okay. Now that we've condensed that, what I recommend doing is dealing with those 10s. So we have, let's see, which one's smaller? Let me write what we've got again, just so we can all see it better. We have this on top. We said negative 4 was smaller, so we'll cancel it. That's minus a negative 4 on the bottom. We'll have to be careful here. Since it's scientific notation, it's actually probably a better rule of thumb to just bring it up top. Do you guys want to do that so I don't have to do confusing steps at the end? If it were X's, I would definitely take it on bottom. But what's going to happen when we divide? Where would that number go when I divide 33.6 divided by 4.2? Would it be on top or on bottom? It goes on top. So that's what would cause us some error here. If we did you'd have a number on top of a 10 to a power. That's okay. Just pull the 10 back up. Do you want me to proceed by erasing it and bringing the 10 from the bottom up and showing you how to do that? Or do you want me to wait and do that, pulling the 10 to the top in the very last step? Last step, so keep on doing like we're doing? Okay. So we have a 10 on the bottom to the 6th power. Now when we divide these numbers, we're going to get a single number over 1, right? What do we get? An even 8? So we have 8 over top of 10 to the 6th. That's good. The problem with scientific notation is we kind of like to have them together. And you can shift it across, I mean, as long as you have multiplication attaching to it, right? When I bring this up, what happens to the sign? And when you cross the bar, the sign becomes negative. And we're choosing again to cross it because we like all of our numbers to be together. That makes sense to us. So now you have 8 times 10 to the negative 6. That's your scientific notation. If it wants it in decimal form, okay, move your decimal. So you have, I'm going to put 8 way over here since it's going smaller. 1, 2, 3, 4, 5, 6. With a decimal, something like that. That's what we thought. Good. That was a good question. I'm glad we worked that one out together.